Hello and welcome to this video where we are going to go over one of the problems in Leetcode, which is about maximizing the profit as a salesman of houses. First, let's go over the problem statement. So we are given n houses and we have to maximize our profit while selling them. We're also given, let's say, m number of offers. And offer is starting index of the house, ending index of the house, and the money that we are going to get for, for that offer. Few constraints are that uh, the offers cannot overlap. So if we sell one house to one of the offers, we cannot sell it again to another one. Uh, and the other is that the order of offers that we accept doesn't matter. So we just have to get the maximum number of money. And we don't even have to have the list of offers that we would accept in order to get this money. We just have to return the maximum amount of gold that we can earn. Usually, I recommend, and it's generally recommended to first solve a problem on pen and paper. In case we are not familiar with this problem, it's going to help us to understand it better. It's going to help us validate our ideas. If we come up with something, we can run it as some algorithm. We can run it over this example and see if we get the desired result or not. It will also help us to find some patterns that we can use to create the solution itself. If we are not familiar with the problem, it's very helpful to first go over an example. So let's start with an example, and we're gonna choose a small set of houses. Let's say we have 6 houses starting from, okay, yeah, starting from 0. Okay, so we have 6 houses. Let's go 7. Uh, we have 7 houses and we get some offers and we have to find the best combination of offers that we can accept and get the most money. So for the offers, we'll create a table that's going to be start and and G for gold. Let's create some random example which is going to just help us understand the problem. It just has to satisfy the conditions, as in the start should be less than equal to the end, and the offer can be any positive number. Actually, in the problem statement, it says the offer should be less than 1,000, but that's not really important for us at this point. All right. So let's say and also let's consider what other constraints we have. one of them. So the number of houses is potentially can be up to 100,000, same as the number of offers. This just tells us that we should uh, think about how what the complexity of our solution is, because we cannot choose solution with high complexity. It's gonna time out and we're gonna fail. So, but first we can start from the more complex solution with uh, the bigger complexity, and we can simplify it, optimize it as we go. So let's say uh, we choose the first offer, right? And we can see that it overlaps with a few other offers. And from this, we already know that we cannot choose this one because one starts from one and this one ends in two. So they overlap. We chose the first offer, then we cannot choose this one either. This one is okay. This one is also okay. This one is not okay. So we see that there is this, after we make a choice, we rule out some other offers that we cannot choose later. So in this case, we basically have I guess, a combination of offers that we can choose simultaneously, and we just have to pick num the the, the combination that gives us the bigger sum of this column G. If we construct, for example, if so this choosing the maximum, to choose the maximum, we basically can just iterate over all the possible combinations and find the one that says the maximum uh, sum. So if we were to do that, we would, for example, let's say we try to go over all the possible combinations. So first we choose the first offer, right? And let's index them from zero. So this one is going to be our zero offer. If we chose it, that means we later we can only choose from uh, this offer, this offer, this one, or this one, because all the others, these three others are overlapping with the first one. So uh, in this case, we, for example, can make a decision about choosing the this one. This is the fourth one, which is indexed number 3. So for example, if we choose this offer, later we will have to rule out this one because 5 is in this range as well, and this one because 5 and 6 are in this range, and this one too because 4 and 5 are in this range. So in this case, uh, we earned 5 plus 3. So in this case, we would earn like $8. Okay, and what if we don't choose the first one? Let's say we don't choose it and we move on to the next one. So the next one, for example, we try to choose the second one. Okay, it's giving us $7. We know that we cannot choose from this one is ruled out because it overlaps with the first offer. This one is also overlaps, starts with 4. This one doesn't overlap, so it's still valid to choose. try to this one. Let's, yeah, let's say we skipped over this one and yeah, we skipped over this one. We chose this one. We cannot choose this one. It overlaps. This one overlaps. This one is fine. This one is fine as well. This one overlaps. And this one again overlaps. 0, 3, and 1, 4. They overlap. So we are left with these two possible choices. Let's say we choose this one, and it's the fifth one. Its index is 4. So let's say we choose this one, and it of course overlaps with this. So next stage we cannot choose this one, and we are left with 7 plus 2, which is $9. So we can see this choice was better than this one. Okay, so this is a small example, a few combinations that we considered. And what can we conclude from this? First of all, I can conclude that after I make a choice, after that I go over all of the offers and try to find the ones that are overlapping or that are not overlapping to know which ones I can choose next. So this means for if we go over every possible choice of choosing or not choosing any offer, we have to every time go over all the offers to find the ones that are overlapping. So we can optimize this by trying to group the over overlapping uh, offers together. So for example, if I knew that all the offers that are going to overlap with this one are located near it, and I knew that, for example, after this index, I don't have to go any further because I know that after this index, all the offers that come will not go to overlap with this second offer. So we can do that by the sorting this offers array. Uh, we have to make a choice what to sort it. What's going to be the sorting strategy for us? If we choose to sort, uh, let's say a start index, right? In that case, uh, we would after we sort everything, uh, if we reach a certain index, if we know that we will know that all of the offers that come after it uh, are going to have start index bigger than or equal to this current one. So for example, if we've reached an offer that has start equals to 5, we know that everything that comes after it is going to have start bigger than or equal to 5. That's going to help us to just stop the search and just pick the and just assume that everything that comes after doesn't overlap. So for example, if we chose the offer 4, if we chose the offer that ends with 4, we know that we cannot choose anything that overlaps with it. But what doesn't overlap with it? The offers that start from 5. So if we find the offer that starts with 5, everything that comes after is not going to overlap, and we just can consider everything that comes after as the next choice in our this list of combinations. So that's gonna help us uh, to reduce the number of possible combinations that we consider. So let's do that. For example, let's just create a second table, which is going to be sorted. Just gonna clean this up. Yeah, let's just sort by start time, right? So we have, and this is gonna be easy because our numbers are small and we can just, so the first one is, let's say, remains this one. Second one is going to be this because it starts from 0. And it doesn't matter where, the algorithm doesn't consider if the end time, end house is less or bigger than the next one's end house. So this is just a consequence. This the of that we have the first one first in the index in the array, but it's not important. Uh, yeah, let's say the second one, we can choose this one as the second, as the third one to illustrate that the actual order is not important. Take 1, 5, 8, 4, 7, and comes to 2. We don't have anything that starts with 2. 3 we don't have either. So then comes 4, 5, 4, 4, 6, 3, and 5, 5, 6, 1, 5, 5, 2. Okay. After we ordered, let's try to do the algorithm again. So we choose the first one as an example, we choose it, then we have to find all the ones that are overlapping and cross them out. So the end index is 2. Uh, we go through all the offers until we find the one that starts with the number that's bigger than 2, which is this 4, and everything after this is not going to overlap. As we can see, it's not overlapping. So looks like our algorithm was correct. Can try on this one as well. Or let's say on this one, so it ends with 5. So everything that starts with bigger than 5 is not going to overlap, and everything is overlapping. So this shows that we can just see that everything is going to overlap because nothing is starting with index 6. We have a we have first possible solution, and we can start to create a pseudocode for it. Let's first clean this initial table because we don't need it anymore. We created the sorted one, and we can picture our solution here and try to see if it's gonna work, if our algorithm is gonna work. So for example, first we choose this one, as we said, number 0, and say there is a plus and minus. So we did choose it. We choose it, and we can already say that we made $5. Let's try to see how much more we can make. So 2, the end is 2. We need to find the offer that starts with the number bigger than 2, which is, let's say, 3 or 4. So yeah, we found this 4. And from the, as we said, as I said, I'm doing the case where we just go over all the possibilities. So for example, we can, after this one, we can choose this. It's gonna be number 4. And if we choose it, we're gonna make $4. So $4. After that, we cannot find anything that starts with number 6. So this case is done, and we made total $9. We can go back. Okay, if we don't choose this one, we can choose something else. Let's say the other one is makes us 3, right? So if we didn't choose this, we can choose the next offer, makes us $3. So plus 3, and after that it's gonna overlap with everything that comes next, because nothing is gonna, 6 is the last house, so it's gonna cover all the houses. So in this case we made 5 plus 3, $8. Okay, going back, what if we don't choose fifth offer either? We choose the next one, which is gonna make us $1, and it's number 6, offer number 6, and after that it's gonna overlap with everything that comes next, which is, so it's gonna make us only additional $1, which is gonna make $6. If we don't choose it, we can choose the last one, 7, so order number 7, and it's gonna make us $2. So $2, 5 plus 2 equals 7. And like this, we can go through all of the possibilities and consider what's gonna happen, right? So let's create a pseudocode for this so we can understand how it works and try to optimize it. I've already written a pseudocode, so I will just paste it and we can analyze it. I don't want to waste time writing it. Yeah, so just create a comment here, right? Let's do some formatting. Don't need this problem statement. Right, this one looks good. Yeah, so the pseudocode starts from us initiating. So we, as I said, we are going over all the offers and seeing what's what's gonna be the profit when we start from that offer? What's gonna be our profit? And we're trying to find the maximum out of all of this. And what does this function do? It's gonna find us the uh, profit that we have after we choose the given offer. So for example, in our case, if we choose first offer, we're gonna call this function with the list of offers, and offer index will be 0. That means we chose this offer. Now tell me what's my maximum after choosing this. The algorithm takes the next offer and tries to find the offer that doesn't overlap with the offer that we chose, right? If it overlaps, it skips that one. And when it comes to next offer, should be an offer that doesn't overlap with the offer that we just chose. And as long as it's less than it there is such an offer, which means the next offer index is less than the existing number of offers, we recurse into the tree. And for example, we say, okay, so now we found this fourth offer that doesn't overlap with the zero offer index 0, and how much money are we gonna make if we choose this one? And it goes like this until we find all of the go over all of the possible combinations, and we of course return the maximum out of all of the possibilities that come after. So this this function is basically going to go over this loop is going to loop over this one, this one, this one, this one, and try to find the maximum out of all of these possibilities and return it. So in this case, it's gonna, because it's choosing all of the possibilities, it's gonna count to the complexity of 2 power of n, where n is the number of offers. This is going to be a very big number because m is less than equal 100,000. So in this case, we will time out and will not be able to complete the test. So let's consider the problem again and see what can we optimize about it. In this case, let's say we chose 0, right? Then we have 5, 6, 7. Okay, so for example, if we in this case, if we don't choose number offer 0, right? So we have minus. We have all of the other offers to choose from. Comes next the first an offer index number 1, right? So yeah, so what comes after this? We know if we choose index number 1, we'll have two possibilities, either choosing it or not choosing it. Let's say we do choose it. We chose it and we made $6. Now we have to find offers that don't overlap with it. So it's ends with 3. We have to find something that starts with 4 or bigger. And yeah, this is our 4. It is indexed 4. and later we consider this possibility. And after this, uh, we see that, okay, so we have a tree that starts with 4 here, and we have a tree that starts with 4 here. Uh, if we create the actual tree, we will see that they are, they have the same structure, they repeat. It's because whatever we, whatever comes after this is the same in both cases. Like whatever happened before is not important. As long as we have arrived at some offer index, whatever happened before doesn't matter, and we can always make the same maximum amount of profit from this section of the table. Uh, and that's something we can optimize, right? So if we know that if we go over this tree one time and find the maximum, next time we can just save it and use it for the other solutions. We don't have to go over it every time. So we save the offer index, let's say 4, and we save the maximum number that we made here. Of course, not considering this 5 because we don't know about it. So, for example, in this case, we made $4. In this case, we made $3. In this case, we made $1, right? It was 1, yeah. And in this case, we made $2. And they all are mutually exclusive. So this case was basically easier for us. But the idea is that you find the maximum out of this tree that you had, and whenever you see this tree, you can just use use that number. So in this case, the maximum is 4, which is this number, which is our maximum we can get from these 4 offers if we consider only them. So in this case, we can just save it like max equals to 4. And whenever we reach this place, we just know that we can make 4, and that's it. We can stop the algorithm. So to code this in our solution, it's usually done by adding a dictionary of offers and corresponding max max profit. And we call it because we save it in memory, we can call it memo. Let's say it's a dictionary, and if we every time we check if so if we have already done this offer, if we have already considered like what's gonna happen with this offer, we can just return the number. Yeah, it's gonna help us to consider less examples than before. So we have identified the solution that memorizes which offers we have already analyzed and then returns the corresponding maximum profit from that that comes after that offer index. Uh, As we can see, to make a first, let's say, to calculate this first number, we have to go all the way through the to the last offer. Instead of doing this recursively, we can do this iteratively, which is going to make the algorithm easier to understand. And also it's going to help us to do some more optimizations. So instead of starting from the beginning, we can start from the end, and we can, uh, let's say, for example, instead of starting from this offer, we can start from offer number uh, index 7 and see what profit we can have when if we have, for example, everything below this line as an offer. So if we have one offer, we can only make $2 profit. Then we move on to here, right? We we say, what if we choose this one as an offer? We will make $1 profit, and after that we have uh, after that we will have a few options, right? So if we are at the index number 6, we can either take it, which is gonna give us +1, or we can not take it, and which is gonna give us 0. And in this case, we can choose the offer that doesn't choose the offer that comes after it, which is number 7. So for 7, we already have calculated it. Its maximum is equal to 2, so we can just return 2 and say that for this, for offer number 6, the maximum is equal to 2 as well. And for this offer, for example, we can see that, okay, so this one I'm not gonna draw, but if, for example, we choose this one, we're gonna make profit of 3, and it also overlaps with 2 offers that come after, so we can only make 3 profit from this line below this line. And just like this, we go through until the beginning of the array, and whenever we reach the beginning, we already know how much profit, max profit we can make from this line, which in this case we only need to consider like what's gonna happen if we choose this as an offer and remove all the overlapping offers from the line below, or if we don't choose this one and we get the maximum that we can get from this line below. Uh, that's one way to simplify it, and it's also possible to, instead of storing the offers, we can store the start indexes of offers. That's going to give us the ability to quickly find the next start index that we can use. So for example, if we just chose this offer number 3, and for example, we know that this is the start index, we can always search for the next greater index that comes after this one. So we search, if we store these start indexes in sorted order, we can always do a binary search and search for the next bigger number, which is going to be number 4, and we just look up the maximum that we calculated for this number for. So we don't do like iterative search like we did in this pseudocode. Like here we do iterative. We go until we find the offer that doesn't overlap. We just do binary search, which is which takes less time. For these two optimizations, I've created a pseudocode. Let me just copy and we can go over it. So uh, so the one thing we have to mention here is this memo. We need it to be a a sorted dictionary. So in various languages, it's represented in different ways. In Java, it's gonna be a tree map, which is gonna help us to sort everything, store everything sorted, and to get the next bigger start index with log n complexity. So what the algorithm does is starts from the end, as I said before. So it starts from the end, it goes until the first offer in the array, and for each one, uh, it's so this one should go here. Yeah. So for each one, it's the asks uh, finds the next offer, which is actually the finds it using the start or using the end index. So it looks up the end index that's looks up the start index that's greater than the last end index. Uh, and after finding this new offer, it adds its whatever we have stored in our memo, and it adds to the profit for this offer. And that becomes the total profit we can make when we choose this offer. And everything, of course, is at every step we calculate the maximum to we calculate the maximum so we can keep track of when we reach the goal. So we can just keep track of the maximum number because that's what we need. We don't need any other information to return. So this total maximum is going to be maximum over all the calculated profits. And for each offer, as I said, we store the start time and corresponding the profit that was made from that offer and all the offers below. And we return this total max number, which is gonna, in the end, is just gonna be the everything that we have, the maximum of all the profits that we have calculated from all of this. Uh, yeah, and to code this, I will leave the coding for you. I've done it. I will link the code uh, below the video so you can go to it if you want, but I would encourage you to try it first yourself. And if after a few tries, like after two tries, after spending, let's say, 30 or 45 minutes on this, if you can do it, then yeah, of course, go to the solution and read through it. It's gonna have the comments to make it easy to understand. Yeah, thank you for watching. We'll see you next time.